Alright, geometry fans, today our lesson is going to be on your paper, so you're going to need to take out a piece of paper so you can take notes on this. Now, we've been talking about angle measure and arc measure for the last couple days, and we're going to continue with this. So the topic for today is going to be what we call inside angles. Okay, inside angles and arc measure. And by the way, your geometry joke for the day, what do you call an insect that's not feeling well? And the answer is a secant. S-E-C-A-N-T, sick ant, haha. Okay, so when you look at a circle, if we were going to put an angle somewhere in this picture, you've got four places where you could put it. You could have the vertex at the center. Okay, so on the side here, I'm going to make a little chart here. So vertex versus arc measure. Vertex and arc measure. If the vertex is at the center, then the arc measure is going to be the same as the angle measure. Okay, so we call that a central angle, and that's going to be the same as the arc measure. This is what we talked about a few days ago. So let's say that the angle measure is 72 degrees, then that means the arc measure is also 72 degrees, if that's a central angle. Okay, and let's go ahead and say that that's the center P, and we'll name this the circle with the center at P. So if it's a central angle, the arc measure is the same. If the vertex of the angle is on the circle, then we know that the angle is half the arc measure. So let's say that the arc measure is 72 degrees. Then we know that the angle measure, the inscribed angle, is 36. So if it's a central angle, the arc measure is the same as the angle measure. If the vertex is on the circle, then we know that the angle is half of the arc. We know that the angle is going to be 1/2 of the arc measure. So if the arc is 72, half of that is 36. Now, there are two more places that we could put a vertex. Okay, one place would be, what if we draw the angle and the vertex is somewhere inside? Okay, so the vertex is somewhere inside the circle. Okay, now that's what we're going to talk about today. And then the fourth possibility is you could put the vertex outside the circle. Now we'll talk about that tomorrow. For today, we're going to talk about what happens in this situation where it's inside the circle. Well, we're going to prove the relationship that we're going to be using. And so to do that, let's go ahead and call this angle 1 right here. And now here's the thing about this angle. You know vertical angles are congruent. So those two angles have to be congruent. Well, in this case, you actually get two arcs that you create from this. See, angle 1 is intercepting this arc up here, and then its vertical angle, which is also the same measure, is intercepting this angle down here. Now let's give these points some names. Let's call this A. We'll go around the circle. There's B, there's C, and there's D. So the thing about an inside angle is you actually have two arcs to deal with. Well, so how are we going to do this? Well, let's go ahead and we're going to draw a chord from A to B. Okay, we're going to connect this right there. Now what that does is that creates a triangle. And you have angle A and you have angle B. Let's call angle A, let's just number that with a 2. That's angle 2. And then angle B, let's number that with a 3. And let me try to focus this a little bit better. Well, okay. So there's angle 2 and there's angle 3. Now, the thing about this, angle 1 is an exterior angle of this triangle. If we extend this side here, we're creating angle 1. Now, there's a relationship that this exterior angle, okay, angle 1 equals the sum of the two remote interior angles. So that equals angle 2 plus angle 3. Well, that doesn't help us very much because we want to talk about the arc measure. Look at angle 2. That is an inscribed angle because the vertex is on the circle. Well, central angle is the same as the arc measure. On the circle is half the arc measure. The angle's half the arc. So angle 2 has to be half of the arc measure, which is BC. So we're going to say angle 1 equals, that's half the arc measure of BC, plus angle 3. Now angle 3 is here at point B. That's also on the circle, so that's half of the arc measure. If I trace out angle 3, I get point D and point A. So that's arc AD that gets intercepted. The inscribed angle is half of arc AD. Now let's clean this up a little bit here. You could factor out the 1/2. So it's 1/2 times arc BC plus arc AD in parentheses. And I'm going to write it, instead of multiplying by 1/2, let's just go ahead and add the arcs and divide by 2. And that gives us the relationship here. You add arc BC and arc AD, and then you divide by 2, and that gives you this angle here somewhere inside the circle. Okay? Now, the way that I tend to think about this, when you add two numbers and you divide by 2, well, that's what we call an average. That's what we call an average. Okay, so if we go back to our chart, the central angle measure is the same as the arc measure. If the vertex is on the circle, it's going to be half the arc measure. If it's somewhere on the inside, it's the average of the two arcs. You get two arcs with an inside angle. Okay? And if you look at the picture again, angle 1 creates two arcs here, arc AD and arc BC. So how do you find angle 1? You add the two arcs and you divide by 2. Okay, now I'm going to stop the video for a second and then we'll look at a couple of examples.